All right, so we've been talking about polynomials. The first lesson we were just like a basic review, just an overall talking about polynomials. On 5.2, we actually did some stuff with some polynomials. Okay, we added, we subtracted. So what do you think would the next step be after adding and subtracting? There it is right there. It's multiplying, right? And dividing as well. You know what? I haven't even looked far enough in this lesson. I've actually written notes on the next two lessons, and they don't do dividing yet. Maybe at some point they will do that. But again, this is a brand new book for me, so I'm kind of just a little ahead of you guys, tell you the truth, with this stuff. So let's talk about this. Let's do some real basic ones first. The most basic multiplication. We're going to deal with exponents. We actually talked a little bit about this yesterday, but not this exact thing. Remember yesterday we took an exponent to another exponent. What did we do with those exponents? So like it was x cubed squared. What is that? What is x cubed squared? What do we do with those exponents? You multiply them together. So what is x cubed squared? X what? Give me one answer. It's x cubed squared. X to the 6. X to the 6, because you multiply the exponents. 3 times 2 or 2 times 3 is 6, correct? So it's x to the 6th. All right, this one, it's a little different. When we usually teach that kind of stuff, the thing I'm going to do right now usually comes before that thing that I just said, that x squared, or whatever I said, x cubed squared. What is that what I said? Yeah. All right, so this is kind of just like a little review problem. This is taught back in Algebra 1, okay, maybe pre-algebra. I can't remember. It's been years since I taught pre-algebra. So it's x cubed. It's been years since I've taught Algebra 1. All right, so let's take a look at this. If I said x cubed times x to the 5th, this is not x cubed to the 5th power. This is a multiplication of x cubed times x to the 5th. So what x cubed means is this. That's x cubed. X times x times x. What's x to the 5th? Well, it's how many x's? 5 of them. Okay? So if I'm multiplying these together, what am I doing? I'm putting x how many times? How many x's do I have here? I have 8 of them, right? So I've got 8 to the x. Now, instead of doing this, that'd be ridiculous. If I had something like this, if I had x to the 17th times x to the, 29th, it would be really dumb to write this down 17 times and write this down 29 times and add them up. Would you agree with that? Yeah, that would be ridiculous, okay? So we need a little rule. Okay, we did it with these little ones, okay, made it pretty easy. So what is our rule with our exponents? You just add the exponents together. As long as you have the same base, this only works when you have the same base. It's got the same base. What do you do with the exponents? You add them up, okay? And that's all there is to it. All right, so like if you did this one right here, what would this be? X to the what? 30 and 27 is what? 47 and minus 1, 46, is that right? All right, so that would be x to the 46. What's the rule? You add the exponents. So that's really important. This is a multiplication problem. This is not an addition problem, okay? This is a multiplication problem. And then what do we do to the exponents? You add them up. Keep the base the same, and you add the exponents. It's what I've said that throughout my math teaching career. I probably said it thousands and thousands of times. You add the base, you keep the base the same, and you add the exponents. All right, enough of that. Let's do one that's a real example. That was just kind of getting us prepped for this. So example 1, it says you're going to multiply all these together. It's got the word multiply in front, so that's what I'm going to do. So I've got 3x squared in parentheses, and then 6x cubed in parentheses. All right? It's pretty basic. It's kind of like this one, except they got some numbers in front. Remember, this is a multiplication problem, so we are multiplying things together. So this 3 and this 6, what am I doing to those two numbers, 3 and 6? I'm multiplying them. What is that? What's 3 times 6? It's 18. All right, then I've got the x's. I've got x squared and I got x cubed. So now, what do? I got the same base, so I keep the base the same. I heard it. You add the exponents, and what is that? It's 5. That's it. That's all there is to it. Everybody with me? All right, let's do another one. It's just a little bit more involved in this, not much. Just going step by step here. Now remember, with addition and subtraction, we can only add what? When we add and subtract, we can only add what kind of terms? Like terms, okay? Like terms. With multiplication, it's not the same. I can multiply two bases or two variables that are different. I can multiply them together, all right? So for instance, before we get to this, let's do this. What if I just said, what is A times B? Let's do it like this. What's A, put a dot in B. What's A times B if I was to rewrite that? Just AB, that's all it is. So I can multiply them together, all right? I'm not really doing a whole lot to them, but I can multiply them together. Everybody see that? What if I had this? What if I had A squared times B cubed? It's just A squared B cubed. That's right. That's really the only thing we can do to it, okay? But they are being multiplied together. Everybody got that? So you can multiply things that have different bases. Let's take a look at this now. What I'm going to do, this is all multiplication. There's no addition, no subtraction, no division. It's all multiplication. So what am I going to do here? I'm going to go take your regular numbers, negative 8 times 2, and multiply those together. What do I get? Negative 16. All right. Now what I'm going to do is I'm going to take the x's, multiply them together, then I'm going to multiply the y's together and just put them together. So let's take a look. I've got an x here and an x here. Well, what's my exponent? If you don't see one, there's always a 1 there. That's x to the first. This is x to the first. So x times x. What is x times x? X squared. So I've multiplied the x's together. Now I multiply the y's together. So I've got a y here. That's y to the first. That's y to the first. And what do I get? Again, y squared. All right. What did I do with the exponents? X to the first, x to the, let's see. Yeah, x to the first times x to the first. What did I do to those exponents? 1 and 1. I added them, right? 1 plus 1 is 2. Same thing with the y's. Pretty basic, pretty simple. Do you agree? Let's do another one. Again, a little bit more involved. Same idea, but just a little bit extra stuff. All right, here we go. The hardest part are the actual numbers themselves, okay? And I probably couldn't do that in my head. I probably did it on a calculator or something and put down the answer, so I'll just write it down. So what we're going to do is multiply the numbers. I got a 2 times negative 7 times negative 12. And when you multiply them together, I won't make you do the math. It is positive because you got a negative times a negative. So that's positive 168. Now let's do, it doesn't matter what order you go in. Normally though in math, we kind of go in alphabetical order. We don't have to. It doesn't make any difference. It won't make it right or wrong if you don't put it in the right order. But normally we would do it in alphabetical order. Okay, so let's just do it that way. So let's do the A first. So let's multiply all the A's together. So I got an A cubed here. There's no A's here. I got an A to the first right there. So I'm going to get A to what power? We got cubed, got 1, so it's going to be what? The fourth. Very good. All right. Let's do the B's. So I got a B to the first right there, B to the second, no B's there, so that's going to be B cubed. As easy as that. All right, and let's do some C's. No C's here. We got 1 here. We got 4 here. So how many do we have? C to the fifth. And they are all being multiplied together. But you only multiply the A's together, the B's together, and the C's together when you have exponents like that. And then just put them next to each other, and that's it. Looks like a weird answer, but all these answers kind of look like weird answers. But that's how you do it. Pretty basic. Do you agree? Yeah, you learned this a long time ago, didn't you? Remember doing this? My guess is Algebra 1. I'm sure you did it in Algebra 2. Almost guaranteed. So let's do another example. It's a little bit more involved. This time we're going to do something that we've talked about before, but we're really going to put it into practice right here, and that is distributive property. So let me give you, again, a little review. Distributive property problem. Yeah, that's right. So here it is. Everybody in here should be able to do this, basically with your eyes closed, I hope. All right? And we've actually done some distributive, haven't we? In here when we simplified those polynomials before we added and subtracted. I think we did some distributive before, so it shouldn't be new. So I'll do this. Every math teacher that's ever lived has probably done this. Put these little arrow from there to there, there to there. Sometimes you put an arrow. Sometimes you're lazy and don't. And then we just multiply. And we multiply that 3 by everything in the parentheses. So we multiply it by x. What's 3 times x? It's just 3x. Then you put the sign, which is plus. And then you go 3 times the next one. 3 times 2 is 6. It's as simple as that. Well, they're going to be a little bit more involved, all right? But that's the basics. That's the real basics. So now let's do an actual example from the book. This is part A. They give you 3 of them. So let's write that down. 3x squared, 6xy, plus 3y squared. You could go across like this, but it seems like, I don't know, when I do these, at least on my paper when I did them, I kind of just put it underneath here. So what we're going to do is take that whole entire 3x squared and we're going to multiply it by this first term. Then we're going to take that 3x squared and multiply it by the second term. So really the math is the same as what we've been doing, but it's just a little bit more involved than what we did right there. So here we go. 3 times 6 is 18. X squared times x, that's x cubed. Why? Because we add the exponents. And then there's no y here, but there is a y here, so we got to multiply it there. So that's my first term. Plus, then we do it to this. We take that whole entire 3x squared, we multiply it by this whole entire 3y squared. So 3 times 3 is 9. There's no x's to multiply, so I just keep it x squared. There's no y's to multiply, so I just keep it y squared. That's it. We're done. It's as easy as that. Again, that's part A. Part A is always the easiest one. The more we go, the more difficult they get. But it's not going to be much more difficult. So we've got 5x cubed y squared. We've got xy cubed. We've got minus 2 x squared y. All right, here we go. We're going to take this thing on the outside and we're going to distribute it. It might be the last time I put those little arrow things there, okay? Hopefully you get the idea. So what do we do here? I got a 5. I don't have a number here, but technically it's a 1, isn't it? So I really am multiplying 5 times 1, which is 5. I got x cubed times x, which is x to the 4th. Y squared times y cubed. What do I do with the exponents in this situation? I add them, so what do I get? That's 5. Y to the 5th, 2 plus 3. Again, a lot of people mix up whether you multiply them together or whether you add them together. All right? You only multiply it when an exponent is being taken to another power. We're not having that here. Okay, that's not going on right now. We're just multiplying together, so you keep the base the same and you add the exponents. All right, let's keep going. Put the minus here. 5 times 2, that's a 10. The x's, that'll be x to the 5th. The y's, that'll be y cubed, y to the 3rd. That's all you got to do. You're done. It's really not much more difficult than that part A. I'll leave that there so you can see it. All right, let's do one more of these, and then we're going to branch out to something that's a little more difficult than what we're doing right here. So here we go. We've got negative 2ab squared, parentheses 3bz minus 2az plus 4z cubed. All right, here we go. I'm not going to put the arrows here, but I'm going to go through a little quicker this time. Here we go. It's negative 2 times 3. It's negative 6. There's no a, so you just put the a there. B squared times b is b cubed. And then you got a z, so you put a z. All right? Almost as fast as you could write. You should be writing these things down. Now, negative times negative. That's a place where people will get tripped up a little bit. But what's negative times negative? That's a positive, so put a plus there. Now you can go ahead and multiply. 2 times 2 is 4. A times a is a squared. B squared, z, and you're good to go. Plus, actually, I shouldn't put plus. Why? Because it's a negative 2 times a positive 4. Negative times positive is negative. Let's multiply. 2 times 4 is 8. And then I got an a, I got a b squared, and I got a z cubed. There wasn't much with that. And that's it. That's all I can do. That's that thing multiplied together. All right. Now, this is where you still should have seen this stuff before. Okay, what we're going to do right now, but it's a little bit more complicated than this, just a tad. But it's still an Algebra 1 topic. I hate saying that, but it still is. Example 3. I'll tell you what, before we do the actual example 3, again, let's do like a little review. This is the kind of stuff that you probably already know how to do, and you might have a word that you associate with it. So this time, on all the other ones, look what we did. We multiplied a monomial by a polynomial. Everybody see that? A monomial has just got one term. This is one term. It's being multiplied by 3 terms here. This monomial is multiplied by 2 terms, monomial times 2 terms, okay? Same thing, all these. These are just a monomial times a monomial, all right? But look what we have here. What are we multiplying together now? We're multiplying 2 what? Are they monomials? What's the first one in parentheses? What is it? How many terms? What is it? 2. There's 2 terms, all right? The x and the 2. So this is what kind of a nomial? It's a binomial. So this is a binomial times a what? A binomial. All right, so there's a certain way to do this. It's still distributive property, but teachers teach they use another word that is actually a mnemonic device. You ever heard that word? Mnemonic actually starts with an M. What does that mean? Oh, did I spell it wrong? Yeah, that's it. Mnemonic. Okay, there it is. It starts with an M. I don't know why they do. It's weird in English sometimes they do that. But they call it a mnemonic device, meaning the first letter of each word makes another word, okay? Does anybody remember what that is off the top of their head? Something you talk about in algebra all the time. It's like this. Watch. It's really distributive property. So watch. You're taking the first one. It's a key. Taking the first one, multiplying it by the first one. Then you're taking it and multiplying it by the second one. But what about this 2? Well, then you got to take the 2 and multiply it by the first one, and take the 2 and multiply it by the last one. Any of those words? First, last, nothing's ringing a bell? FOIL. That's right. It's okay, I didn't hear you. So it's FOIL. What in the world does FOIL mean? Well, the F is the what? It's the first. The O is the out. Yes, a lot of you say outer, but I always say outside, so I'll say outside. The I, if that's outside, what do you think the I is? Inside. And then the L, I said that. What is that one? That's the last. So when you have a binomial times another binomial, you can use the FOIL method. And the FOIL method is first, outside, inside, last. So the first are the x and the x. So we multiply those together. So let's do that. What's x times x? X squared. And now we do the outside. Which ones are the ones on the outside? The x and the 3. They're both positive, so what's my sign going to be? Positive. And now I multiply x times 3. How do I write that? 3x. Yeah, you always put the number out in front. Okay? Now we do the inside. The inside are these 2 right here. So we multiply, and again, they're both positive, so we put plus. 2 times x is just 2x. Then we do the last. The last are the 2 and the 3. They're both positive, so it's plus. 2 times 3 is 6. Do we leave it like that and circle it? No, we don't. Okay, we got to add like terms. All right, so now we're going back to the last lesson that we did. Make sure you add like terms. There's no like terms with x squared, so we keep it that way. These 2 are like terms, so we add them together. 3x plus 2x is just 5x. Is it 5x squared? Do we add the exponents? You only add the exponents when you're multiplying the bases together. You're not multiplying the bases together, you're just adding them. Plus 6. So that would be your answer for a simple little binomial times binomial multiplication. Is this ringing a bell? Yeah? Yeah. I don't think, we haven't talked about this year yet, have we? I don't think so. So let's do the real example 3. They give you 2 of them. It's a little bit more complicated, not much, but just a tad. All right, so this is part A, for example, 3. 3x plus 2 times 4x plus 9. Tell you what, I'll give you 1 minute to do this. Ready? Go. So come up with an answer. You try it. You might have to write it down. Might be a little bit difficult to do in your head. First one you could probably do in your head. This one, you might want to write it down. Yeah, you're going to do FOIL on this. It's a binomial times a binomial. So that's when you do the FOIL method. If you want to put the little arrows there like I did earlier to help you, it's perfectly fine. I'll start you off. So we're going to multiply those together. That's my first. That's my outside. This is my inside. And this is the last. So you're going to write them down, and then you're going to have some like terms. You're going to have to add up your like terms, put it all together, and then you're done. All right, a minute's up. Anybody get an answer? What was the first part? 12x squared plus, what's that? 27 and 8. What's that? 35x plus 18. You got it. So you after you get used to doing this, you probably could do some of these in your head. All right, but we're not going to since we're just teaching it for the first time. So let's do it. First, what's the first? It's 3x times 4x, which is 12x squared. If I really wanted to, if I was actually teaching this for the very first time, let's say you're in Algebra 1 class, okay? 9th grade, Algebra 1, and I was teaching this for the very first time, this is probably what I would write down. I would go 3x times 4x. Everybody see that? So they know which ones you're multiplying together. Then you do the outside. Put a plus. Everything's positive, so everything's going to be plus. Do the outside. It's going to be what? 3x times 9. Let's do the inside. It's going to be 2 times 4x. And let's do the last, 2 times 9. Sam, what's going on? Do you have an early dismissal, or you just have to go? All right. Okay. Enjoy. All right, so if I was teaching an Algebra 1 class and this was the first time you ever saw this stuff, this is what I would write down. I don't know if it makes it easier or harder, but you could see the multiplication. All right, so now what we're going to do, and you probably don't have to do this. There are some problems that we're going to do a little bit later that this is really beneficial. But anyway, right now you don't need to. 3x times 4x is 12x squared. And then what's this? Plus 3x times 9, which is just 27x, plus 2 times 4, which is 8x, plus 18. Now we add like terms. These two right here are my like terms. So I keep that the same. That's 35x. That's 18. So that's how we got it. And again, after you do these a while, you might be able to go right here to this, just doing that in your head. All right, but these are the steps. You probably could skip that step. I would go from here to here is what I would do first, and then add your like terms. It's pretty basic, isn't it? Yeah? You probably like doing stuff that you've already done before, don't you? Especially this stuff, because this probably wasn't hard when you first learned it. And especially now that you've seen it, it's probably refreshing your memory. You're like, oh yeah, I remember doing this. All right, just for the sake of time, let's just do this together. So here we go. So 3x times 3x is 9x squared. 3x times 4 is 12x. That was the outside. The inside is plus 3x, and then the last is plus 4. We're not done. Don't leave it like this. If you left it like this, listen, on a quiz or test, if you left it like this, I'm going to mark it wrong. I hate to do it because technically you did your steps right, but you always need to simplify. All right, so you add your like terms, and that would, oh, I forgot the x there, didn't I? Plus what? 15x plus 4. And that's your answer right there. Now, if you wanted to put it in a different order, I wouldn't mark it wrong, but you always put it in descending order. Notice it is in descending order. The x squared goes first, then the x, then the constant. All right, let's do one with some negatives in it, so we might as well do this one, part C. Everything's been positive. That's been pretty easy. So we got to make sure we can keep track of our negatives here. There it is. 4x minus y times 2x plus 3y. All right, let's do it. FOIL. First, outside, inside, last. So first is 4x times 2x. They're both positive, so it's both positive 8x squared. Outside, positive 4x, positive 3y. So this is a little bit weird because now we got two different variables. Did you notice all these other ones only had one variable? This just had x. This one's got an x and a y. All right, so the steps are the same, but your answer just looks a little different than what it did before. So what do? We did the first, now we do the outside. 4x times positive 3y, and that's positive 12xy. That's the outside. Now the inside. Here's where you have to deal with the negative. The inside is going to be a minus because it's a negative times a positive. It's minus. You could put y times 2x, but that would look really weird. We always write 2xy. Okay. Again, it's nice to have it in alphabetical order. Do you have to? No, you don't have to, but everybody does. All right. So that's what we got here. Let's do the last. Okay. Negative y times positive 3y. So negative times positive is negative. This is a 1 times 3, which is 3. Y times y, which is y squared. Don't forget the square. One more step and you're done. You add like terms. Those are your like terms right here. So you keep this, 8x squared. You add those up. 12 minus 2 is 10, positive. And then you just write the xy. That's my like term. And then minus 3y squared. That's it. You are finished with that one. All right, got a couple more. Yeah, we got some time. That's good. We're moving right along. They call these special products. And we're going to see in another lesson why they're special. Okay, I'm not going to get really big into it right now. What? All right, so this is example 6, and this is part A. There's 2 of these, A and B. So here's the first one. It looks different than what we just finished doing, but really it's the same exact thing. But let me explain it to you a second. What do you do when you square something? So if I had 3 and I squared it, what am I doing to that 3? Am I multiplying it by 2? Is that what I'm doing when I'm squaring it? I'm multiplying it by itself. Okay? Everybody see that? Anytime you multiply something, what does it mean to be x squared? What does that mean? It means x what? Times x. Everybody with me? All right. What does it mean to be like 3xy in parentheses squared? What that means is this. It means 3xy times what? 3xy. Now we learned a rule for exponents, but that's what it means. What does this mean right here then? Is it? I went through that whole thing so you wouldn't say that, and you said it. What do you do when you square something? You multiply it what? By itself. You multiply it by itself. That's the key. That's why I went through these 2 things right here, well, these 3 things right here. So, what are you squaring? X plus y. So look, everybody look, this is important. So, you're squaring x plus y. So that means I take x plus y and I multiply it by what? Not x times y, x plus y. Okay? This is a super important step. This is a step that, oh my gosh, I'm on this dumb family group text and they keep on texting each other. All right, so this right here, it's not a dumb family, it's my family. I love my family. It's just the group text is the dumb thing that I hate. I hate group text so much. All right, so anyway, x plus y times x plus y. That's super important. You know what a lot of people do? Watch, here. I'm going to do this off to the side. This is my off to the side thing. Here, and Alex said it, not to embarrass you, Alex, but this is a very, very common thing. Alex is not the only one that would do this, okay? Many people would do this. a lot of people look at this and say, oh, let's just square everything in here. Let's just go x squared plus y squared. That looks like it should work, doesn't it? It looks like you're just distributing that through there. But there is no distributive property with exponents, okay? We don't have a distributive property with exponents. We only have distributive property, okay, with numbers. Let's do one that's not. There we go. Oh, keep going. There we go. We only have distributive property, okay, with numbers that are being multiplied times each other. All right? So let's go back to this. This is not true. Don't ever do that. It's a very, very common mistake that students make all the time. Don't you be the one that makes that mistake. I'm going to show you. It's x plus y times x plus y. That's what x plus y in parentheses squared means. So now, what can we do with this? What if I only wrote that down? I bet you everybody in here could have figured that one out, right? You just do the FOIL method. But I bet you anything, there would be at least more than one person that would have gone x squared plus y squared. Would you agree? You might be one of them. And that's fine. It looks like you should be able to do that, but you can't. So we're going to do the FOIL method, okay? This is not the answer, but we got to FOIL it, okay? So let's FOIL this. So let's FOIL this thing. So x times x is x squared. Outside, what's it going to be? xy. Inside, what's it going to be? xy. Plus, last is y squared. Add up like terms. Do we have any like terms? Yep, these two in the middle are like terms. So it's x squared plus what? 2xy plus y squared. Okay? It's a special, what do they call it? Special what? Products? It is a special product. We're going to do something later on, not in this lesson, but in, I think, the next lesson. We're going to actually take this right here, and we are going to change it into that. All right? I'm not going to talk about that any more than I just did. Let's do another one. We will. Might be a little less than what I originally put on there. I don't know. We'll see. We don't have enough time. But here's the next example. I'll let you try this on your own. What if you had this? X plus y times x minus y. Let's do it really quick. We could probably do this in our head. What's the first term going to be? X squared. What's the outside going to be? Negative 8xy. What's the inside going to be? Positive xy. What does negative xy plus xy come out to be? Positive xy minus xy. 0. It comes out to 0xy. And then what's the last term? Minus y squared. Now we don't write 0xy. How are we going to write that answer? We're going to write x squared minus y squared. Now again, this is another thing that we're going to learn probably in the next section or maybe a section after that. We're going to actually end up coming from here, from this answer, and we're going to get that. Those are two special products. So it's very important to see.
That's crack-a-lacky, big dog.
What section was this? 5.3. Actually, I don't even have lesson 5.3. I don't even have 5.3 on the... So I'm going to go no homework tonight. We still have a couple more things on this lesson to do. But not today. We'll do it tomorrow. Yeah, we'll see you.